6 weeks ago, a group of scientists agreed, in writing, that if we ever hear from another civilization, we do not answer back. Not until every nation on Earth has weighed in through the United Nations. Nobody has ever convened that meeting. Nobody currently knows how anyone would start. The document is real. It was ratified on the 5th of June 2026 by the International Academy of Astronautics. It is the first full rewrite of those rules in more than 15 years, and the people who signed off on it are not doomsday preachers. They are the ones who have spent entire careers listening for a voice. They want to find someone. They have already decided that answering back is not their call to make alone. If that lands somewhere behind your ribs, hit like and subscribe, and tell me in the comments what you'd do if the microphone were yours. Then turn the lights down. We're going into the trees. Start with a hole in the ground in Puerto Rico. In the early 1960s, engineers found a natural sinkhole in the limestone hills near the town of Arecibo, and they lined it with mesh. The dish they built was 1,000 feet across. For more than half a century, it was the largest single radio telescope on Earth. Tourists came, movies were filmed there. Astronomers slept in a bunkhouse on the ridge and walked out under the platform at night, where the cables sang faintly in the wind. Most people know Arecibo as an ear. That's the part we like to remember. A giant, patient ear tilted at the sky, waiting. It was also a mouth. Arecibo carried a planetary radar. That means it didn't just receive, it transmitted at enormous power in a tight beam and then waited for the echo to come back off a distant rock. This is how we mapped the surfaces of asteroids we had never visited. It's how we measured the spin of Mercury and looked through the clouds of Venus. It's how we tracked the objects that cross our orbit, the ones that could one day hit us. In February of 2025, a team led by Sophia Sheikh at the SETI Institute published a paper with a simple, unnerving premise. Forget hypothetical aliens with hypothetical super technology. Imagine instead a twin of Earth, with exactly the instruments we have right now, sitting somewhere out there. How far away could that twin be and still notice us? They went through everything. City lights on the night side, the heat islands of our urban areas, our satellites, the lasers our observatories fire into the sky to sharpen their vision, the chemistry we've pumped into our own air. Every kind of mark a technological species leaves on its planet, laid out on a single scale of visibility. One thing won by an enormous margin. It beat the nearest non-radio competitor by a factor of 1,000 in sheer detection distance. Planetary radar. Detectable, according to that analysis, out to something like 12,000 light years. Sit with the shape of that number for a moment. It isn't the distance to the nearest star, it is a substantial fraction of the way across our galaxy. Inside a bubble that size, there are hundreds of thousands of stars, and most of them have planets. The signal thins as it travels, of course, and it only goes where we pointed it, and the odds that anyone was standing in the beam are small. All of that is true. Here is the part that isn't comforting. We didn't build our loudest instrument to say hello. We built it to defend ourselves. Every time we swept a beam across an incoming asteroid to work out whether it was going to hit you, we were also broadcasting the precise technical fingerprint of a civilization that has learned to look after itself. The very act of watching for the rock that could end us was the act that made us loudest. And the telescope is gone. In August of 2020, a cable slipped out of its socket and tore a gash in the dish. In November, a main cable snapped. On the 1st of December, the whole 900-ton platform came down into the bowl. There is video. It takes about 3 seconds. Half a century of one of the great instruments in the history of our species, folding into a cloud of dust and shredded aluminium. The telescope is dead. The beams are not. Nothing in physics can call them back. Every pulse Arecibo ever sent is still going, spreading outward. 186,000 miles of new distance every second. And it will keep going long after every person watching this is gone. There is no recall button on a photon. There has never been one, and there never will be. Remember the dish. We're going to come back to it. Now let me build the world we were living in before any of this got complicated. Because it was a beautiful world, and it was built by serious people, and for a long time it made complete sense. In 1959, two physicists at Cornell, Giuseppe Cocconi and Philip Morrison, published a short paper in the journal Nature. Their question was disarmingly practical. If another civilization wanted to be heard, what channel would they choose? Not a random one. They'd want a frequency that any species anywhere would already be watching for physical reasons. Hydrogen is the most common substance in the universe, and cold hydrogen gas hums at a very specific radio frequency. Every radio astronomer in the cosmos would have that frequency in their equipment already. So look there, the paper suggested. It costs almost nothing to look. The following year, a young astronomer named Frank Drake pointed a telescope in Greenbank, West Virginia, at two nearby sun-like stars and listened. He called it Project Ozma. He heard nothing worth keeping, and he started something that has never stopped. Underneath all of it sat an assumption so natural that nobody thought to write it down. The assumption was that contact would be a conversation. That the other side would be, in some recognizable sense, a colleague. Two intelligences on two rocks, separated by an inconvenient gulf, finally comparing notes. It's a hopeful picture, and it is also a specific picture. And once you have seen it, you cannot unsee how much it takes for granted. The rest of the picture kept getting better. We used to argue about whether other stars had planets at all. Now, NASA's confirmed tally has passed 6,000, with more than 8,000 more candidates waiting in line. Rocky worlds, water worlds, planets in the temperate zone where liquid water could sit on a surface without boiling or freezing. We haven't found a twin of Earth yet, but we found the raw material for one, over and over, in every direction we've bothered to look. And the chemistry is the same everywhere. That's the quiet miracle at the centre of all of this. The carbon in a distant nebula behaves exactly like the carbon in your blood. The physics that runs a star 400 light years away is the physics that runs the sun that's warming the roof over your head. Whatever else is out there, it is made of the same handful of ingredients, obeying the same rules in the same universe. And that is either the most hopeful fact in science, or the most dangerous one. Two small things before we go further, and I want you to hold on to them. The first is a year, 2029. Something we did is going to arrive somewhere in 2029. The second is a piece of paper. In 2015, 28 people put their names on a single page. We'll get to what it said. For now, go back to the beginning of the loud era, because it started at Arecibo too. On the 16th of November 1974, there was a ceremony. The dish had just been upgraded, and someone thought it should be marked with something more memorable than speeches. Frank Drake wrote a message. Carl Sagan and a handful of colleagues helped shape it. It ran to 1,679 bits, which sounds arbitrary until you notice that number is the product of two prime numbers, 23 and 73. Arrange the bits in the grid of that shape and a picture appears. The picture was a postcard, the numbers 1 through 10, the atoms that make up life, the structure of DNA, a stick figure of a human being, the size of our population, a diagram of the solar system with the third planet nudged out of line to show you which one we're standing on, and a schematic of the dish itself, so that whoever received it would know exactly what kind of thing it shouted. Name, address, biochemistry, return contact. It was aimed at a globular cluster called Messier 13, roughly 25,000 light years away. The transmission lasted about 3 minutes. Everyone in the room understood the arithmetic. The message will not arrive for 250 centuries. Any answer would come back 50,000 years after the day it was sent, to a planet where nothing recognizable as us is likely to be waiting. So they weren't making a phone call. They were making a gesture. At a distance, no gesture can survive. And yet the content was still a set of directions. Now compare that to the document from 6 weeks ago, the one that says no reply is to be sent. In 1974, we opened the conversation without being spoken to first. In 2026, the same community formally agreed that even if someone speaks to us, we hold our tongue. Something changed in those 52 years, and it wasn't the physics. Not everyone waited 52 years to object. Martin Ryle was one of the most decorated scientists alive at that moment. He'd effectively invented a whole technique of radio astronomy. That same year, 1974, he shared the Nobel Prize in Physics. He was the 12th Astronomer Royal of Britain. He was also, by all accounts, a man who did not soften his opinions for anybody's comfort. Within days of the Arecibo transmission, a furious letter landed on Frank Drake's desk. Ryle had also gone to the International Astronomical Union, an organisation he had once presided over, and asked them to formally condemn what Drake had done. Broadcasting our position, he argued, was reckless, and he meant that as a plain description, not an insult. The Union declined to condemn anything. Drake replied politely that the distances involved were far too great for any invading fleet. Notice what that answer quietly concedes. It doesn't say the worry is silly. It says the worry is impractical at that particular range, which means the argument was never actually settled. It was postponed, and it has been sitting there ever since, gathering interest. 3 years later, something arrived. On the 15th of August, 1977, a radio telescope in Ohio called Big Ear was doing what it always did, letting the sky drift across its field of view while a computer printed columns of numbers on continuous paper. A volunteer astronomer named Jerry Eman took the printout home to check it a few days later. In one column, he found a run of characters far above the background, rising and falling exactly the way a genuine point source in the sky would rise and fall as the Earth turned. He circled it in red pen and wrote one word in the margin. Wow. The signal lasted 72 seconds, which is precisely how long that patch of sky stayed in view. It sat almost exactly at the hydrogen frequency Cocconi and Morrison had recommended 18 years earlier. It was narrow, strong, and clean. It came from the direction of Sagittarius, and it never, ever came back, despite decades of people going back to that same spot and staring at it. For 47 years, it was the best thing we had. Then, in 2024, a team led by the astrobiologist Abel Mendez at the University of Puerto Rico at Arecibo went back to it properly. They pulled decades of unpublished Ohio observations out of storage, applied modern methods, and combined it with archive Arecibo data. Their leading hypothesis is that a cold cloud of hydrogen gas in our own galaxy was hit from behind by an intense burst of radiation, possibly from a magnetar or a soft gamma repeater, and briefly flared. If that's right, the WOW signal was the first recorded flare of that kind ever seen at the hydrogen line, which would be a genuinely important discovery in its own right. Note the honesty in how that team talks. They've said that terrestrial interference is very unlikely to explain it, and that an artificial origin still cannot be ruled out. They found weaker signals with the same character in the archives, in multiple places on the sky. They have an explanation they like, and they are still carrying doubt around with them on purpose, because that is what the job requires. But watch what happened to the shape of the thing. For half a century, the WOW signal was a question. Now it's most likely an answer about hydrogen. That same year, 1977, we did something that cannot be undone. 2 spacecraft left Earth for the outer planets, Voyager 1 and Voyager 2, and each carried a gold-plated copper disc. Most of the attention goes to what's on the record. Greetings in dozens of languages. Whale song. A baby crying. Bach and Chuck Berry. The sound of surf. It is, without exaggeration, one of the loveliest objects our species has ever made. The dangerous part is on the cover. Etched into the aluminium, below the instructions for how to play the thing, is a diagram that looks like a starburst. 14 lines radiate out from a single point. Each line represents a pulsar, the collapsed core of a dead star, spinning and flashing with a rhythm as distinctive as a fingerprint. Along each line is the pulsar's period, written in binary, and its distance from us. Any civilization that understands pulsars can use that diagram to find the point where all 14 lines meet. That point is you. And it does something even more specific than that. Pulsars slow down over time, very slightly, very predictably. The periods carved into the cover are the periods as they were in the 1970s. So a sufficiently patient reader can compare those numbers to the current rhythms and work out not just where we live, but roughly when we left. The map says here we are, and it also says this is the century we learned to leave. Frank Drake designed it, with Carl Sagan and Linda Salzman Sagan. Decades later, Drake was interviewed about that decision by a journalist who happened to be his own daughter. His answer is one of the quietest and most devastating things anyone in this field has ever said. He described the mood of the era and the people he worked with, and then he said this: "In those days, all the people I dealt with were optimists. Not liars, not fools, just optimists. And optimism in 1977 was not an unreasonable position. It was simply a position nobody had ever been forced to defend. Somebody was about to force it." In 1983, in the Quarterly Journal of the Royal Astronomical Society, an astronomer named David Brin published a long, strange, methodical paper called The Great Silence. It is not a paper about aliens, so much as a paper about the shape of an absence. Brin took every available explanation for why the sky is quiet and laid them out side by side like a coroner sorting evidence. Most of them were comfortable. Maybe intelligence is rare. Maybe radio is a brief phase. Maybe everyone moves on to something we can't detect. Two of them were not comfortable at all, and Brin said so plainly. One was ecological collapse. The other was the possibility that something out there has been actively removing new civilizations, using self-replicating machines that spread on their own and switch on when they hear something. That idea already had a name in the literature: deadly probes. What made Brin's treatment so hard to dismiss was his conclusion about that scenario. It is entirely compatible with everything we observe. Nothing in our data rules it out. And if it were true, it would mean there is nobody left out there to find, and that we may already have announced ourselves. He didn't stop there, and this part matters, because a good scientist doesn't only carry the frightening version. Brin also sketched a gentler possibility. Perhaps some elder civilization, long-lived and genuinely wise, established a tradition of restraint. Perhaps the silence is the silence of a nursery, where the adults keep their voices down so as not to wake the child in the middle of its long and colourful dreaming. Both stories fit the data perfectly. That is the actual horror of a quiet sky. It will confirm whatever you bring to it. Meanwhile, out in the world, the shouting had become a hobby. Through the late 1990s and into the 2000s, a series of transmissions went out from a Soviet-era radar dish at Yevpatoria on the Crimean Peninsula. They were called Cosmic Call. The messages were long, mathematically structured, and aimed at real, nearby stars, rather than a cluster 25,000 light-years away, which means the arrival dates are dates you can actually mark in a calendar. And for about $15, a member of the public could have their name included. Then, on the 9th of October 2008, the same dish transmitted something called a message from Earth. 501 messages and images, selected by public vote on a social networking website that no longer exists, aimed at a planet in the Gliese 581 system, roughly 20 light-years away. That's the year I asked you to hold on to. The signal passed the moon in a little over a second and left the solar system inside a day. It has been travelling ever since. It arrives in early 2029, which is to say, at some point in the next few years, on a specific date, a package of internet comments chosen by teenagers in 2008 will wash over an alien sun. No committee approved it, no government authorised it, no treaty prohibited it, because no such treaty exists. A television production company and a social network did it, and it worked, and it cannot be stopped now by any power on this planet. That is the moment the argument stopped being theoretical. 7 years later, on a campus in Berkeley, a single page of text was drafted and circulated for signatures. It was not dramatic, it didn't mention invasion or monsters. It said that transmitting to unknown intelligences carries unknown and potentially enormous consequences, and that a decision on that scale should not rest with whoever happens to own a powerful antenna. It asked for a worldwide conversation before anyone did it again. And then, in the middle of the page, one sentence that does all the work. It is impossible to predict whether ETI will be benign or hostile. 28 people signed it. Elon Musk, the planet hunter Jeff Marcy, the physicist Paul Davies, George Dyson, Dan Wertheimer, who has spent his life building the instruments that listen, and David Brin, still arguing 32 years after his paper. That's the piece of paper. Keep it in view, because in a little while it's going to matter a great deal what happened to those signatures. So now we have the shape of the puzzle. We have a hopeful search, a set of loud gestures, a small group of people saying, "Wait!" and a sky that has said nothing back. And you might reasonably conclude that the sky has already answered. Nobody's home. The silence is the result. Be careful here, because this is where almost everyone gets the logic backwards. In 2018, 3 astronomers at Penn State, Jason Wright, Shubham Kanodia, and Emily Lubar, published a paper asking a question nobody had properly quantified.
How much of the search have we actually done?
The problem is that looking for a signal isn't like scanning a field. You aren't searching an area, you're searching a space with many dimensions at once. Which direction on the sky? Which frequency? How faint a signal you could pick up? How long you happen to be pointing there? What kind of signal you'd even recognise? Miss on any single one of those and you miss entirely, no matter how good your telescope is. They built an 8-dimensional model of that space and worked out the fraction we've covered. Their own comparison is the one worth keeping. All the radio searching our species has ever done, added together, amounts to roughly the volume of a large hot tub, taken out of all the water in all the oceans on Earth. Feel the shape of that for a second. Not a swimming pool's worth of ocean examined and declared empty. One hot tub. You dip it out somewhere off the coast, find no fish in it, and conclude the sea is sterile. So the silence proves very little. That should be a relief, and for a moment it is. Now here's the part that takes the relief away. Every single time something did show up, it dissolved. In April of 2019, the Parkes telescope in New South Wales, the one the local Wiradjuri people call Muriang, was watching Proxima Centauri. Proxima is the closest star to the Sun, 4 light-years away, and it has a planet sitting in the zone where water could stay liquid on a surface. The observations were originally about stellar flares. The data went into an archive. The following year, an undergraduate summer student named Shane Smith was given the unglamorous job of combing through it. Near the end of his project, something popped out. A narrow, pure tone at about 982 MHz. It drifted slowly in frequency, the way a signal from a moving planet should. It appeared when the telescope was pointed at Proxima, and vanished when the telescope looked away. It persisted for hours, which rules out an aircraft or a passing satellite. And it never repeated, not in 39 hours of dedicated follow-up. It was, by every rough test, exactly the thing we have been looking for since 1960. They called it BLC-1, and the team spent the better part of 2 years trying to kill it. That's the job. You do not announce. You attack your own result from every angle you can invent. The work was led by Sophia Sheikh, then a graduate student, and it turned into a general framework for verifying any future candidate. In 2021, the verdict came out in 2 papers in Nature Astronomy. BLC-1 was human. It was a byproduct of ordinary electronics somewhere on Earth, a kind of ghost tone generated when common clock oscillators interfere with each other. Once they knew what to look for, they found dozens of similar ghosts at related frequencies. Not aliens. Somebody's cheap circuit board humming in the dark. 3 years after that, the same erosion happened on a much larger scale. A project called Hephaestus, based in Sweden, went hunting for Dyson spheres. The idea, first floated by Freeman Dyson in 1960, is that a civilization hungry enough for energy would eventually start capturing the output of its own star, and that whatever it built would give off waste heat in the infrared. So you look for stars that are too bright in the infrared for what they are. They ran 5 million stars through a filtering pipeline built on data from Gaia and 2 infrared surveys. Almost everything fell away. At the end, 7 objects were left, all small red dwarf stars, all glowing in the infrared in a way that ordinary dust disks struggle to explain. 7 candidates out of 5 million. Then other astronomers went to work on them, as they should. Radio surveys turned up sources sitting suspiciously close to 3 of the 7, slightly offset from the stars themselves. High-resolution follow-up on one of them showed the offset object was a distant, dust-choked galaxy, blazing in exactly the infrared bands that had made the star look strange. The most likely story is now contamination, something enormous and far away, sitting behind something small and near, blurring together in an instrument that couldn't separate them. That is what the record looks like. Erosion, not suppression, not a cover-up. Every candidate that has ever raised a pulse in this field has, so far, come apart under examination. And it has come apart honestly, usually at the hands of the very people who most wanted it to be real. And now put the two halves together, because this is the crack the rest of this rests on. We have searched a hot tub's worth of ocean. Everything we thought we caught turned out to be our own reflection, and the sky is still quiet. Those facts are compatible with a universe that is genuinely, profoundly empty. They are equally compatible with a universe that is full and holding its breath. You cannot tell the difference from the inside, no matter how carefully you listen. An empty room and a room where everyone has gone silent because you walked in sound exactly the same. There is no measurement, no telescope, no amount of patience that separates absence from concealment, as long as concealment is being done competently. So the question stops being, where is everybody? That question has an infinite number of comfortable answers. The question becomes something sharper. Is there a reason a rational civilization would choose silence? A reason built from arithmetic rather than shyness or a treaty? And if that reason exists, does it apply to us? The version most people have heard came from a novelist. That's worth saying plainly and up front, because this whole field is littered with ideas that got promoted from fiction to fact while nobody was checking the paperwork. In 2008, the Chinese writer Liu Cixin published a novel whose title translates as The Dark Forest. In it, a character lays out 2 starting assumptions about any living thing, anywhere. Survival is its first need, and the total matter and energy available is finite, while the appetite of a growing civilization is not. From those 2 premises, the book derives an image so vivid it has escaped the book entirely. The universe as a forest at night. Every civilization is a hunter moving through the trees, careful, quiet, armed. If a hunter hears something in the dark, they cannot know what it is or what it intends, so they fire first. It's a fantastic image. It is also a novelist's argument, and it deserves to be tested rather than repeated, so let's take it apart properly. Because when you push on it, the weakest pillar collapses almost immediately, and what's left standing underneath is much worse. Start with the resources. The scarcity argument is the shakiest part of the whole structure, and serious researchers have said so for years. The galaxy is not a crowded island. There are hundreds of billions of stars, most with planets, and the overwhelming majority of the raw material in any system sits in places nobody has to fight over. Asteroids, ice, gas giants, sunlight. Crossing light years to take a planet from someone else, when uninhabited systems are available in every direction, is roughly as sensible as flying to another continent to steal a bucket of seawater. So if the dark forest depended on greed, it would fall over. Good. Let it fall. What remains is the second pillar, and this one is not made of economics. It's made of geometry and time, and neither of those can be argued with. Consider a real case rather than a hypothetical. A little over 12 light years from here, there's a small red star called Lytton's star with a planet in its temperate zone. In 2017, and again in 2018, a non-profit called METI International, working with a music festival in Barcelona and a Catalan Space Institute, transmitted a series of messages at that planet from an antenna inside the Arctic Circle. The transmission included a mathematical tutorial designed to be decodable by someone with no shared language, and dozens of short pieces of music. They also did something oddly touching. They put the date of our next appointment inside the message. They told whoever might be listening exactly when we would be at the receiver, waiting for an answer. The 21st of June, 2043. Think about what kind of conversation that actually is. A question asked by one set of people, answered to a different set. Anyone who was 30 when that message went out will be in their 50s before a reply could physically arrive. And Luyten's star is a close neighbour, one of the nearest systems with a plausible world. Push out to 100 light years, still a tiny corner of the galaxy, and a single exchange consumes 10 human lifetimes. Now try to build trust on that timetable. Picture yourself in a stairwell during a power cut. Pitch black, concrete, no windows. You have a flashlight in your hand, and you can hear someone breathing on the landing above you. Neither of you can see the other. You'd like to know if they're dangerous. On Earth, that situation resolves in seconds, because you can speak. You say something, they answer. You hear the tone of the voice, the tension in it, the fact that they answered at all, and within 1 or 2 exchanges, you have a workable read. Now change one rule. Every sentence you speak takes 12 years to reach them, and their answer takes 12 years to come back. You can no longer negotiate. You can only make declarations into the dark, and then wait most of a lifetime to learn what they meant to whoever heard them. And the stairwell analogy breaks in a way that matters. In the stairwell, you at least know your words arrived. Across 12 light years, you don't even get that. You cannot confirm the other party heard you, understood you, or exists. All you know for certain is where you were standing when you spoke. That's not a communication problem, it's a verification problem. And verification is a thing every peaceful relationship on Earth is quietly built on. But even that isn't the sharp edge. Here's the sharp edge. Suppose you get a message and, against all odds, you decode it, and it is unmistakably gentle. A greeting, some mathematics, a little music. Every instinct you have says these are not monsters. You are not looking at who they are, you are looking at who they were when the light left. If they're 100 light years away, you have just received a photograph of a stranger's childhood, and you are being asked to bet your species on the assumption that they grew up kind. Ask what a century does to a civilization, and don't ask about aliens, ask about us. In 1901, Guglielmo Marconi got a faint pattern of clicks across the Atlantic, and the world called it a miracle. 60 years later, we were bouncing radar off Venus and reading the echo. Within a single long human life, our species went from barely making a noise across an ocean to shouting across the solar system and hearing the reply. Then we crossed from that to landing people on another world, and then to building the 1,000-foot dish that could be heard, at least in principle, a good fraction of the way across the galaxy. Nobody in 1901 could have modelled that, not one person. The curve doesn't announce itself in advance. So when you receive a friendly message from 100 light years out, the honest translation is not, they are harmless. It is, they were harmless. Once. And I have no way to find out what happened next. Any civilization capable of doing that arithmetic will do it. Because it isn't paranoia. It's just reading the clock. That's the third pillar, and it holds weight. The one after it is where I have to be careful with you. Because this is exactly the point where this kind of story usually starts lying. Nobody has ever built an interstellar weapon. Nobody has ever detected one, or found evidence that one was ever used. And any confident claim otherwise is fiction. What we can do is look at what known physics permits, and note where the numbers land. 10 years ago, a project called Breakthrough Starshot, funded privately and advised by some very serious physicists, proposed sending a probe to the nearest star. The design was elegant. You don't carry fuel. You build a huge array of lasers on the ground. roughly 100 gigawatts of combined power, and you fire it at a reflective sail the size of a bedsheet, with a gram of electronics attached. 10 minutes of that beam, and the sail is moving at a fifth of the speed of light. The project itself has since quietly wound down. Reporting in Scientific American in September of 2025 described the effort as effectively over. The engineering was brutal, and the money didn't follow. The physics did not wind down, and the physics has an uncomfortable symmetry to it. A beam powerful enough to accelerate a sail is a beam powerful enough to destroy whatever else it touches. A machine that pushes something to a fifth of light speed is a machine that can throw something at a fifth of light speed. Kinetic energy grows viciously with velocity. At those speeds, an object weighing no more than a coffee cup is carrying the energy of a very large bomb. And it doesn't need a warhead, or a guidance system, or a crew. It just needs to be aimed a long time ago. I want to be explicit, because this genre survives on being trustworthy. That is an extrapolation of known physics. It's the kind of thing a working scientist would call speculative, but not stupid. It is not a discovery, and no one has seen it happen, but notice the consequence, because the consequence is structural, and structure is what makes a trap. Any defense requires warning. Warning requires that information about the threat reaches you before the threat does, and nothing carries information faster than light. So a projectile moving at 9/10 of light speed arrives almost simultaneously with the first glimpse of it. Whatever you are, however clever you are, the gap between seeing and being hit shrinks toward nothing. Attack is cheap. Attack is anonymous. Attack does not require you to travel, negotiate, or ever be identified. And defense, against that, may not be a thing that exists. Which brings us to the last piece, and it is the one that turns a strategy into a trap. You cannot take it back. Every other dangerous decision our species has made has had, somewhere in it, a thread of reversibility. Treaties get renegotiated, weapons get dismantled, borders move. Even the worst environmental damage is, in principle, something a determined civilization could work at for centuries and partly undo. A transmission is different in kind. The instant it leaves the antenna, it is no longer yours. It is a fact about the universe now, expanding outward at the same relentless speed as every signal before it, and there is no authority, no technology, and no future genius who can reach out and gather it back in. Think about the last letter you were ever nervous to send. The moment your fingers open above the slot and the envelope drops, and there's a fraction of a second where you'd give anything to have it back in your hand. That fraction of a second is the entire experience of interstellar messaging. Except the envelope never lands, and it keeps going, and it will still be going when the sun is a different colour. So line the pieces up. You cannot verify intent. You cannot know their present, only their past. Their capabilities can explode faster than any message can cross the gap. A strike is cheap and effectively undefendable. And nothing you say can be unsaid. Now here is the inversion, and it's the reason this idea refuses to die, despite decent people trying to kill it for 40 years. Nothing in that list requires anybody to be evil. Read it again. There's no villain in it. No hunger, no cruelty, no empire, no appetite. Not one of those 5 conditions describes a monster. They describe a situation. And a rational, decent, peaceful civilization, looking honestly at that situation, might arrive at silence, not because it wants to hurt anyone, but because it cannot prove to a stranger that it won't, and it knows the stranger is doing exactly the same arithmetic about it. That's the trap. It isn't cruelty. It's the impossibility of demonstrating that you're harmless to something that will never see your face, never hear your tone, and cannot afford to be wrong even once. You have never had to do that, not once in your life. Every time you've reassured somebody, you've had a face, a voice, a shared room, a history, a reputation, 100 small human proofs available in the first 3 seconds. Strip all of that away, leave only a signal and a distance, and there is no move you can make that a careful stranger should trust. which leaves one question sitting in the dark, and we have been very carefully not asking it. Not whether they are hiding, whether we ever could, because there is a calendar. Almost nobody knows it exists, and it is entirely real, and some of the dates on it fall inside your lifetime. In April of 2036, a signal transmitted from a radar dish on the Crimean Peninsula will wash over a red dwarf star in the constellation Cassiopeia. It contains mathematics, images, and the names of ordinary people who paid a small fee to be included. In September of 2044, a second one arrives at a star in Andromeda, the constellation rather than the galaxy. In May of 2049, another reaches a star in the Great Bear that you can see with your naked eye on a clear night, if you know where to look. It is called 47 Ursae Majoris. It has planets. Nobody voted on any of this. The transmissions were organised privately, sent from a dish originally built to talk to Soviet spacecraft, and the content was assembled from public submissions. A production company did one of them, a music festival did another. There was no international body involved, because there is no international body with the authority to be involved, and there still isn't. And 2 of the letters have already been delivered. That's the sentence I want to sit at the centre of this. Not will be, have been. According to the published arrival estimates, a message transmitted in 2009 swept over a small, dim star called Teegarden Star in 2021, 12.5 light years from where you're sitting. Another arrived at a red dwarf in Aries 3 years after that. While you were doing something ordinary on a specific Tuesday you don't remember, our mail landed. If anything was there, it has already had the envelope in its hands for years. And if it chose to answer immediately, the answer is already most of the way here. There's one more entry on the calendar, and it's the one that stays with me. In 2012, a television channel answered the wow signal. Hold what that sentence contains. We have had exactly 1 candidate detection in the entire history of the search. 72 seconds, never repeated, source unidentified to this day. We didn't know whether it came from a civilization, a cloud of hydrogen, or a piece of equipment misbehaving somewhere on Earth. We had no idea what was at the far end, or whether there was a far end at all. We answered it anyway. The National Geographic Channel ran a promotion tied to the launch of a series about unidentified flying objects. Anyone with an account on a social platform was invited to submit a message during a single evening window. More than 20,000 of them arrived, along with video clips from a handful of celebrities. On the 15th of August 2012, exactly 35 years to the day after Jerry Eamon circled that column in red ink, the whole bundle was transmitted from the Arecibo dish toward the patch of sky the original signal came from. The engineers took the job seriously, which is somehow the strangest part of it. They attached a repeating header to the front of the transmission, so that any receiver would immediately register the thing as deliberate and made by something intelligent. They chose an encoding built to stand out against natural noise. They wanted it to be understood. That is careful, thoughtful technical work. The payload was 20,000 social media posts and a comedy bit. I'm not mocking the people involved. Some of it is genuinely funny. Nobody meant any harm, and the chance that anything was listening rounds to nothing. What matters is the mechanism underneath. A marketing campaign for a cable program reached out, borrowed the most powerful transmitter our species has ever operated, and replied on behalf of all of us to the only unexplained signal we have ever received. Nobody asked permission, and nobody had to, because there was no office anywhere on Earth whose job it was to say no. There's a reasonable objection to all of this, and it is a good one, and it comes from a peer-reviewed paper rather than from anyone trying to make you feel better. In 2013, in the journal Space Policy, 4 researchers led by Jacob Hack-Misra ran the numbers on exactly how loud these deliberate messages actually are. They compared every intentional transmission we've ever sent against the ordinary background racket of a technological planet. Their conclusion was blunt. Our deliberate shouting is orders of magnitude weaker than our routine noise. The messages are brief, they're aimed at one point. They're pitiful compared to the great sweeping beams of military and astronomical radar that we run without thinking about it at all.
which sounds like an enormous relief for about 4 seconds. Then you notice what it actually says. The part of our behaviour we argued about, wrote statements about, and eventually built protocols around, is the quiet part.
The loud part was never up for debate. It's just infrastructure. It runs on a schedule. Nobody signed anything. Let's take the loud part seriously then, because there's a myth here that needs killing. You have probably heard some version of the idea that our old television broadcasts are out there, expanding in a sphere, and that somewhere out among the stars, an alien civilization is watching black and white sitcoms from the 1950s. It's a lovely image. It's also wrong. And it's wrong in a way that matters. In 2023, 3 researchers, Ramiro Saidi at the University of Mauritius, along with Michael Garrett and Nalini Hiralal Isur, published a study in the monthly notices of the Royal Astronomical Society that did something nobody had done before. They took a global database of mobile phone towers and modelled the combined radio power leaking off our planet, then asked what that would look like from 3 specific nearby stars. The result is oddly beautiful. The leakage isn't steady, it pulses. As the Earth turns, whole continents of transmitters rise over the horizon and set again. So from a fixed vantage point out among the stars, our planet flickers on a 24-hour rhythm. Brightest when the most densely wired parts of the world are facing you. And then the verdict. A civilization within 10 light years of us, using an instrument as good as the Green Bank telescope, would not detect it. Our accidental chatter is a whisper. All those billions of devices, all that traffic, and from 4 light years away, it doesn't rise above the noise. Garrett's own summary of the trend is worth keeping in mind. He has pointed out that Earth is already unusually bright at radio wavelengths for a planet, and that if the trend continues, we may not stay undetectable for long. So set the balance sheet out honestly. Our accidental noise is faint. Our deliberate messages are faint but pointed. Our planetary radar is enormously loud but intermittent and narrow, and the dish that produced most of it is a heap of wreckage in a Puerto Rican sinkhole, which, if you were building a case for hiding, would look almost survivable. There's one more line on the balance sheet. You can switch off a transmitter. You can dismantle a radar. You cannot switch off the air. Look at what an astronomer actually does when we study a distant world. We wait for it to pass in front of its star, and we catch the sliver of starlight that filters through its atmosphere on the way to us. Different gases absorb different colours. What comes out the other side is a barcode, and the barcode tells you what that planet is breathing. Now point that instrument at Earth. Our atmosphere is more than 1/5 oxygen. Oxygen is violently reactive. Left alone, it combines with rock and metal and organic matter and disappears from the air within a geological blink. The only way to hold that much of it in a planetary atmosphere is to have something continuously manufacturing it faster than chemistry can consume it. On this planet, that something is life, and it has been doing it at scale for roughly 2 billion years. 2 billion years. Longer than there have been animals. Longer than there have been cells with a nucleus doing anything interesting. Since long before anything on this world had a nervous system, our planet has been announcing to every spectrograph within range that its chemistry is being held out of balance by something alive. That's the biosignature, and there was never a moment when we had the option of turning it off. The technosignature is much younger and much stranger to think about. In 2021, a team at NASA Goddard led by Ravi Kopparapu published a study in the Astrophysical Journal about nitrogen dioxide. On Earth today, most of it in the lower atmosphere comes from combustion, vehicles, power stations, industry. During the pandemic shutdowns, satellites watched it drop over cities in real time, which is what gave the researchers their handle on the problem. Their finding was that for an Earth-like planet around a Sun-like star, a future large space telescope could pick up present-day levels of that gas out to roughly 30 light years, given about 400 hours of staring. Then they added a detail that unsettles me more than the main result. Global levels of that pollutant were around 3 times higher 40 years ago than they are now, which means the version of our civilization that existed in the 1980s, dirtier and less regulated, was significantly easier to detect than the version that exists today.
Our industrial exhaust has a spectral fingerprint. So do the chlorofluorocarbons we manufactured, which have no natural source at all, and are therefore an even cleaner giveaway. The same 2025 analysis that measured how far our radar reaches also noted that this kind of atmospheric marker has become considerably more detectable in the last decade, thanks to instruments like the James Webb Space Telescope. Not because our air changed, because the eyes got better. Ours got better. Theirs would too. Think about a house at night with every light switched off and the curtains drawn. From the street it looks empty. Then you notice the chimney. Smoke, steady, rising into the cold, because whoever is inside is keeping warm. And keeping warm is not optional in winter. The darkened windows are a decision. The smoke is a consequence of being alive in there at all. That's the position, and the comparison breaks in the only place that counts. You can let a fire go out. A civilization that stops breathing, stops burning, and stops manufacturing has not successfully hidden. It has simply stopped being the thing that was hiding.
Which brings the whole argument to its actual conclusion, and it is not the conclusion most people expect. If the dark forest is real, the strategy it recommends was never available to us, not since 1974, not since Marconi, not even since the first fire. The tell was never our radio. The tell is our biology, and it has been running since before there were eyes on this planet to see it. Take a breath here, because I want to say the frightening part quietly rather than loudly. If that logic holds, then a species in our position has exactly one honest description of its situation. We are visible. We have been visible for longer than we have existed, and we have added deliberate signals on top of that for half a century. You already know what that means, because you heard it earlier tonight about a single dish in a sinkhole. It means the same thing here, just at a larger scale. The Arecibo pulses are still travelling. The pulsar map is bolted to 2 spacecraft that have already left the solar system and will drift among the stars for hundreds of millions of years. The letters land on their published dates, whether or not anyone on Earth still remembers sending them. All of that is the waiting, and the waiting is measured in a currency we don't get to spend. You are not the first person to feel the shape of that, and the most famous version of it came from a man who spent his life doing the mathematics of the universe. In 2010, Stephen Hawking narrated a documentary series in which he laid out what he thought contact would actually look like. He was not coy. He said he believed alien life almost certainly exists somewhere, and that attempting to reach it might simply be too risky. His picture was bleak and very specific. He imagined civilizations that had used up their own worlds and gone looking for others, moving between the stars in enormous ships, taking what they needed as they went. Then he offered the comparison that has followed him ever since. The outcome would be much as when Columbus landed in America. He let the rest of the sentence do its own work. Everyone watching understood how that had gone for the people already living there. There's a fair criticism of that image, and it deserves airing. Human colonial history is a story about societies at broadly comparable technological levels, separated by an ocean, fighting over land and labour that both sides could actually use. Almost none of that transfers to beings separated by light years, who would have no use for our bodies, our work, or our biochemistry, and who could find raw material more cheaply in any empty system along the way. So the invasion picture is probably wrong, and the people who roll their eyes at it are not being naive. What survives the criticism is smaller and considerably harder to shake off. Hawking's underlying argument was never really about resources. It was about asymmetry. Anything capable of reaching us would be so far ahead of us that our intentions would have no bearing on the outcome, and our consent would not be sought. Whether they meant us harm would matter about as much as your intentions matter to the ants under a foundation. And he made that argument as a man who put his name to a major project to search for alien signals, and sat on its board until he died. He wanted us to look. He did not want us to shout. That's the ceiling of this argument. Now let me pull it apart, because I would be lying to you if I left it standing unchallenged, and a fear that can't survive scrutiny isn't worth your evening. Most researchers in this field do not believe the dark forest. Their reasons are not comforting platitudes, they're structural, and several of them are very hard to answer.
Start with the requirement the hypothesis quietly makes.
For a forest to stay dark, every single civilization in it, not most of them, has to reach the same conclusion and hold it forever, without one exception. The astrophysicist Moya McTeer put the objection about as cleanly as it can be put. Speaking to National Geographic, she pointed out that we don't even see that kind of unanimity among cultures here on Earth. And she's right in a way that's difficult to argue around. A civilization advanced enough to cross between stars is almost certainly complex enough to contain factions, dissidents, eccentrics, religious movements, and bored teenagers with access to equipment. We're the proof. We can't hold a consistent policy on anything for a single decade. A music festival transmitted at a star because it was celebrating an anniversary. If even one member of even one civilization decides to wave, the forest gets a campfire, and everybody in it can see everybody else, and the equilibrium collapses in a single generation.
There's a second problem, and it comes from a simulation rather than an argument. In 2017, in the International Journal of Astrobiology, the astronomer Duncan Forgan modelled civilizations arising at different times and places in the habitable band of our galaxy, and asked a narrow question: could they even form a shared agreement in the first place? To agree on a rule, you have to know the rule exists. To know it exists, you have to be within reach of someone who can tell you, in time for it to matter. Forgan found that under most reasonable assumptions, the galaxy doesn't produce one connected community. It produces several isolated pockets that have never been in contact and never will be. No galactic club, just cliques, each unaware of the others. That destroys the version of the dark forest where silence is an enforced norm. Nobody could enforce it because nobody could deliver the message. Sit with the flip side of that finding though. If nobody can enforce a rule of silence, then nobody is enforcing a rule of peace either. There is no adult in the room. There is no treaty, no council, no elder civilization keeping order. What Forgan's model describes is a galaxy of strangers who have never met and cannot coordinate, which is not exactly the reassurance it first appears to be. The third objection is the largest, and it may simply be correct. In 2018, 3 researchers at Oxford, Anders Sandberg, Eric Drexler, and Toby Ord, published a paper with the deliberately provocative title, Dissolving the Fermi Paradox. Their argument is about arithmetic rather than aliens. For 60 years, we've estimated the number of civilizations by multiplying a chain of factors together. How many stars? How many with planets? How often life starts? How often it becomes intelligent? Multiply, get a number, be surprised the sky is empty. The problem is that some of those factors are not known to within a factor of 2. They're not known to within many orders of magnitude. We have exactly one example of life starting, and we don't know whether that was nearly inevitable or a fluke that took a universe to produce once. When you feed that honest uncertainty into the calculation as a range rather than a single confident guess, the answer changes character completely. You don't get a number, you get a distribution, and a substantial chunk of that distribution sits at 0. Their analysis found a real probability that we are alone in this galaxy, and a smaller but serious probability that we are alone in everything we can see. If that's right, the silence needs no explanation at all. No hunters, no strategy, no trap. Just an empty forest, and one small animal in it, standing very still for no reason. There is a published response arguing that their conclusion rests almost entirely on how they modelled one particular parameter, which is exactly the kind of argument that should be happening. This is a live disagreement between careful people, and it has not been settled. One more, and this one is about how badly these estimates can go. In 2022, a doctoral student named Alberto Caballero tried to put a number on the risk. His method was to look at how often countries on Earth have invaded other countries over the last century, factor in how the likelihood of invasion seems to drop as societies become more technologically advanced, and extrapolate. His conclusion was that the chance of a hostile civilization invading us as a result of a message we send is roughly 100 times smaller than the chance of Earth being hit by a planet-killing asteroid. It got enormous press. It also got a published rebuttal, arguing that the assumptions underneath it cannot support the weight placed on them, and that the estimates should be rejected outright. Both of those papers exist. Both are on the record.
That is what the state of knowledge actually looks like here, and I'd rather show it to you honestly than hand you a clean number that isn't real. The dark forest is also only one door out of this room. Several of the others are gentler, and one or two are stranger, and you should have them before you decide what to be afraid of. The plainest possibility is that we're listening for the wrong thing entirely. Radio was our first trick. It has been our main way of moving information for barely a century, and we are already migrating our signals onto tighter beams, onto glass fiber, onto lasers, onto anything that wastes less energy spraying into empty space. A civilization 1,000 years past that transition would leak almost nothing at all. Our whole search assumes the neighbours are broadcasting in a manner we happen to have grown up recognising. Imagine standing in a field with a cupped hand behind your ear while everyone around you is quietly texting. Another possibility is that beacons are built to be missed. James Benford and his colleagues argued that anyone constructing a genuine interstellar lighthouse would optimise it for cost, and the cheapest design is not a steady glow in every direction at once. It's a narrow beam sweeping across the sky, illuminating any given target for a few moments every few years. If that's what's out there, we would need to be pointed at exactly the right star at exactly the right instant, and our entire search history amounts to a series of very brief glances. Then there's the door nobody likes. The zoo hypothesis says they already know we're here and have chosen not to interfere. On first hearing, it sounds warm. A galaxy with rules in it, elders who keep them, a young species left alone to work things out on its own terms. Push on the implications and the warmth drains out of it very quickly. If that's true, the silence isn't an accident of physics or distance, it's a policy. A decision taken about us, without us, by something that has been observing long enough to reach one. Our privacy would be a courtesy extended by strangers. Every argument our species has ever had about whether to transmit would be theatre performed for an audience that already knew the ending. Forgan's model damages that idea too, as it happens. A galaxy of disconnected cliques cannot agree on a policy toward anyone. None of these possibilities can be tested right now. That is the honest state of things. We have a silence and roughly a dozen explanations that fit it perfectly well, and no instrument capable of separating them. So take stock. Every serious objection lowers the probability. The unanimity problem lowers it. The connectivity problem lowers it. The possibility that nobody is out there lowers it enormously. The economics of interstellar conquest make almost no sense. The most frightening version of this idea is, by a considerable margin, a minority position among the people who study it professionally. And not one of those arguments takes the probability to zero. That's what makes this different from ordinary risks. You cannot run the experiment twice. There is no version of this where we try it, learn from the outcome, and adjust. A species gets one attempt at not being noticed, and it doesn't find out whether it succeeded until it has already failed. And that should bother you slightly more than a small number normally would. Step back from the forest for a moment, because the same silence that might be a decision could also be something with no decision maker behind it at all. And that possibility is worth taking just as seriously before you trust the trap. The economist Robin Hanson gave it a name in the 1990s: the Great Filter. Begin with dead chemistry on a warm rock. End with a civilization that spreads between stars and can be seen doing it. Between those 2 points, there's a long ladder of steps. Chemistry becomes self-copying. Self-copying becomes cells. Simple cells become complex ones. Complex ones cooperate into bodies. Bodies develop nervous systems, then language, then agriculture, then instruments, then the ability to leave. The sky is empty. So at least one rung on that ladder is nearly impossible to climb. Everything turns on which rung. Picture a long road with a bridge out somewhere along it. You're driving. You don't know whether the collapsed span is behind you, in a stretch of fog you don't remember crossing,
or somewhere ahead in the dark. If it's behind you, the road is clear and yours alone. If it's ahead, you are approaching it at speed, and so has everyone who ever drove this road before you, and none of them made it across.
That's the whole argument, and it has a consequence that reverses how you feel about the most hopeful discovery imaginable. In 2008, in MIT Technology Review, the philosopher Nick Bostrom wrote an essay whose title tells you exactly where it's going. He hoped the search for life on Mars would find nothing, not because he lacked curiosity, because of what a discovery would imply. If life started independently on a second world in our own solar system, then the early rungs are easy. And if the early rungs are easy, the hard one must be somewhere later, which increasingly means somewhere ahead of us. His line about it is one of the strangest sentences ever written by an optimist about the future. Dead rocks and lifeless sands would lift my spirit. The dark forest, if it's real, would be a filter of an unusual kind, built from decisions rather than chemistry or catastrophe. A shape in the logic of the situation that any sufficiently clever species walks into, the way water finds a drain. There's a competing view, published in the Astrophysical Journal in 2021 by Robin Hanson and 3 colleagues, and it flips the perspective in a way that's genuinely disorienting. Their starting observation is that we appear to be early. If reaching our level requires a series of very improbable steps, then the odds of it happening should climb steeply with time, and the universe has an enormous amount of time left. Stars will keep forming and burning for a period that makes the current age of the cosmos look like an opening credit. By that reasoning, the overwhelming majority of advanced life should appear long after today. And yet here we are, near the beginning, apparently ahead of schedule. Their proposed explanation is that fast-expanding civilizations set a deadline. If loud, grabby cultures spread outward at close to light speed and change everything they touch, then they close off the regions they occupy, and any species that appears later never gets the chance. The only civilizations that appear early are the ones that appear before the door shuts. Hanson's own estimate for when we might run into such an expansion front is somewhere around 1 billion years from now. There is a published critique arguing the whole line of reasoning fails in the same way the doomsday argument fails, and that objection has not been dismissed. But hold the picture for a second regardless. In that model, we are not hiding in a dark forest at all. We are standing in a clearing at 4 in the morning, and the reason it's quiet is that the party hasn't started, and we are the first ones awake in the house. Now watch what our species does in practice, because behaviour tells you more than any position paper. On the 1st of July 2025, a survey telescope in the Chilean hills called Atlas caught a faint smudge moving through the constellation Sagittarius. Within days, the orbit was clear. It wasn't ours. It had come in from interstellar space on a path so extreme that nothing the Sun has ever captured comes close. And it was leaving again, and nothing in our solar system's gravity was going to hold it. The third confirmed interstellar visitor in history, after Oumuamua in 2017 and Borisov in 2019. It was named 3I Atlas. Estimates of its age suggest it may have been wandering between stars for billions of years, possibly since before the Sun existed. It has never, in all that time, passed close to any star. Our Sun is likely the first one it has ever properly met. There is no evidence it is anything other than a comet. Every measurement says comet. It grew a coma, it vented carbon dioxide and then water as it warmed, and it behaved exactly the way a very old, very cold lump of ice should behave when a star finally gets hold of it. And we still checked. Breakthrough Listen pointed the Allen telescope array at it within days of discovery. Then, on the 18th of December 2025, less than a day before its closest approach to Earth, they aimed the 100-metre Green Bank telescope at it across 4 receivers spanning a wide sweep of the radio spectrum. At that range, the instrument was sensitive enough to catch a transmitter no stronger than an ordinary home internet router. No artificial emission of any kind. Notice what that operation says about us though, because the result is less interesting than the decision. We took the largest steerable dish on the planet
on a night when 1,000 other things wanted that time, and we pointed it at a rock to check whether it was talking. Nobody expected an answer. The cost of not checking, in the one case where it matters, is unbounded, and that is reason enough. Somewhere in the last decade, without a formal announcement, our species quietly adopted the posture of something that scans the tree line. Some researchers think we're scanning at the wrong distance entirely. In 2019, the plasma physicist James Benford published a paper in the Astronomical Journal proposing a search that almost nobody had bothered to run. His reasoning starts from something already established here. Our biosphere has been advertising itself for an enormous stretch of time. In his words, alien astronomy at our level may have detected our biosphere many millennia ago. If that happened, the sensible response would not be to send a radio message and wait 10,000 years for an answer. The sensible response would be to send something to sit here and watch. And if you were parking an observer in this system for the long haul, where would you put it? Not in orbit around the planet, where it would eventually be catalogued by somebody with a good camera. Benford's suggestion is a class of objects we only began properly cataloguing in the last few decades: co-orbital asteroids. Rocks that share Earth's orbit around the Sun without orbiting Earth itself, sweeping close to us every single year, offering a solid anchor, uninterrupted sunlight, raw material, and near perfect concealment among ordinary rubble. We have barely studied them. Radio astronomy has never targeted them. Planetary radar has never pinged them looking for anything artificial. The idea has a longer history than you'd guess. In the 1980s, Robert Freitas and Francisco Valdez actually ran telescope searches for artificial objects at the gravitationally stable points near the Earth and the Moon, the places where something could sit almost indefinitely without spending fuel. They found nothing. Others since have proposed the asteroid belt, the lunar surface, the cold outer reaches beyond Neptune. Every one of those searches has come back empty, which is precisely what you would expect if nothing is there. It is also precisely what you would expect if we have been looking in a handful of the wrong places, briefly, with instruments built for something else. What makes the proposal interesting is that it is testable in a way almost nothing else in this field is. You cannot fly to another star and check. You can fly to a rock that comes within a few million miles of your face every year, and several agencies already plan to. That's an odd thing to carry around with you, not because it's likely, but because for the first time, one version of the question has an address close enough to knock on. And there are going to be many more visitors. The Vera Rubin Observatory in Chile has begun its 10-year survey of the entire southern sky, using the largest digital camera ever built. Estimates for how many interstellar objects it will find vary widely, which is honest of them, given that our entire sample is 3. The observatory's own figure is somewhere between 5 and 50 over the decade. Some models say considerably more. Whatever the number, the trickle becomes a stream. We are about to have a great many strangers to check. Suppose one of those checks comes back positive. Most people picture that moment as an announcement, a press conference, a stunned news anchor, a statement from a government. That is not how it would go, and the declaration ratified in June spends a surprising amount of its length explaining why. It would begin as an anomaly in a data pipeline, probably spotted by someone junior, probably at an unsociable hour. The first move is to assume the instrument is broken. The second is to assume it's interference from something on Earth. The third is to ask a different observatory, on a different continent, with unrelated hardware, to look at the same coordinates without being told what to expect. Independent confirmation is the entire game, because one telescope can be fooled, and 2 telescopes with nothing in common cannot be fooled the same way twice. That process is slow. Remember Proxima. Shake's team spent nearly 2 years on that single tone, and it still ended in a correction. Something has changed about that problem recently, and it has nothing to do with astronomy. The people who rewrote those protocols said plainly that the reason for the overhaul was the information environment. Social media, the speed of the news cycle, and artificial intelligence, which now means a convincing fake announcement, complete with fabricated data and a synthetic video of a real researcher saying words she never said, can be assembled by almost anyone in an afternoon. Set that against the verification timeline.
The signal might take 2 years to confirm. The rumour takes 90 seconds. By the time the careful people are ready to speak, the story has already been told 10,000 times by people who invented it. The declaration contains one more provision that stopped me when I read it. It includes measures concerning the safety of the individual researchers involved. Somebody sat in a meeting and concluded that whoever finds it will need protecting. Not from whatever sent the signal, from us. That is the world the first real detection arrives into. Not a hushed lecture hall with a careful paper attached, but a screaming feed, in which the difference between the most important discovery in human history and a well-made forgery comes down to who you happen to trust that morning. Which raises the question this whole thing has been circling, and it isn't a question about aliens. Who speaks for Earth? Right now, formally, the Declaration does name somebody. It points to the United Nations. Any reply to a confirmed signal, it says, should wait for consultation through that body, or one broadly like it. That is worth taking seriously, and it is also worth noticing exactly what it does not do. No treaty requires a government, a company, or a private citizen with a working antenna to go anywhere near that process. There is no licensing regime, no oversight body, no penalty for skipping it entirely. Which means the decision belongs, in practice, to whoever owns a sufficiently large antenna and decides to use it. A government, a corporation, a university with an unusual research director, a wealthy individual with a strong opinion and a spare afternoon. Remember the 28 signatures? That page from 2015 asked for one thing. Not a ban, but a worldwide conversation involving more than a handful of people with access to powerful equipment, before anyone spoke on behalf of the species again. That conversation never happened in any binding form. What happened instead is smaller and stranger. The caution won inside the profession and nowhere else. 11 years later, the same instinct was written down again, more carefully, by more people, and ratified by an international academy. The astronomer who led that work, Michael Garrett of the University of Manchester, described the standard of evidence they now hold themselves to with a line I keep turning over. We do not shout alien the moment we see a strange blip. It's a good rule. It's a rule about restraint, discipline, and the refusal to be stampeded. Written by people who would personally love to be the ones who find it, and it is a rule that governs only them. Think of it as a shared house with a front door that anyone inside can open. There's a note taped to it, agreed by some of the residents, listing a number to call first. There's no lock, and nobody is required to dial it, and the door only opens outward, and once it's open, it can never be closed again. That is the actual situation, not a conspiracy, not a cover-up, something more ordinary and harder to fix. A decision that affects every person who will ever live, sitting in the hands of whoever happens to be holding the transmitter, governed by a piece of paper with an address on it, and no teeth behind it. There is something else in that piece of paper though, and I don't want to end without saying it. As far as we know, and we could be wrong, we are the only thing in the universe that has ever asked whether it should be quiet. Consider what that question required. Chemistry had to become biology. Biology had to spend billions of years arriving at nervous systems. Nervous systems had to build culture, and culture had to build mathematics. And mathematics had to build instruments capable of measuring the silence in the first place. Then, at the very end of all of it, something had to look at the result and feel a flicker of unease rather than triumph. That flicker is younger than most of the people watching this. It didn't exist in 1974. Frank Drake said it plainly. The people he worked with were optimists, and it never crossed anyone's mind that the postcard might be a mistake. We learned caution in 50 years. From a species that has been shouting into a dark room since before it had language, that is not nothing. So go back to the sinkhole in the Puerto Rican hills one last time. There's a scar there now,
Cables lie in the vegetation. The bowl is being reclaimed by the same limestone landscape it was carved out of, and the platform that hung above it for 57 years is scrap. The dish is gone. The signal is not. Somewhere out past the far edge of everything we've ever photographed, a thin front of radio energy is still expanding at the only speed there is, carrying the shape of a species that learned to look for danger before it learned to wonder whether it was the danger. We spent 70 years asking whether anyone is out there. That was never quite the right question, and the wrong question is the one that kept us comfortable. The real one is smaller, and it is about us. What kind of thing are we, given that we could not help calling out? Not a reckless thing, not a stupid one. A young one, alone in a very large house, who found the light switch and pressed it before anyone had thought to ask what the darkness was for. And if the forest is real, then somewhere out there is a civilization that made the same calculation we're only now beginning to make, and chose silence, and has been keeping it for longer than our species has existed. Think about what that costs. Generation after generation, knowing, saying nothing, never finding out. They would be the loneliest things in creation, and they would still be here. If this got under your skin, hit like and subscribe, because there is more of this coming. And leave me a comment with a straight answer to one question. If a confirmed signal arrived tomorrow, and the decision were yours alone, would you reply? And where exactly do you think you got the right to decide that for everyone else?